you are looking for the missing angles, right? So we're looking for that missing angle here, or solving for x in this case. So, but we also need to remember that all angles inside a triangle add up to 180. All angles in a triangle add up to 180 degrees. So we're going to use that idea. We know that all angles add up to 180 degrees. So that'll help us find this missing one. So if I know that, if I add all these together, they should equal 180. I can pretty much create an equation used with that. So now it's x plus 103, the first angle, plus the second angle, plus the third angle, should equal 180. Okay? And now all I got to do is solve for x. Get my highlighters here. Make sure this one works. That one doesn't work. Throw that away. Is this one good? Okay. Okay, so here, combine like terms first. Those are terms without an x. So now we have x plus 103 plus 20. All right, and again, just minus 123 here. So 180 minus 123, that's 57. So 57. Now in this case, x represents an angle. So it's not just 57, but it's 57 degrees. So you might make sure you include that little symbol there. So write degree notation. Okay, the little symbol right there. So make sure you guys are doing that. So for example, here on the side, 49 degrees. Always make sure you include that. Okay, I'll pause the video. To math here. So for the second example, we'll do this one. So you can copy this one down as best you can there. Just try to draw that triangle. Okay, so I have 6x minus 16 in one corner. And then I have 6x plus 19 in the other corner. And then 57 degrees in the bottom corner. And then in this case, we need to solve for x. And in both cases, we're actually solving for x, really. But here it's not specifically asking for what are these angles, even though we could look for it. But for delta math in this case, it's not asking you, okay, what is the angle after you find x, which I'll do real quick just to show how you would find that if you had to. But it's not asking for that. And also, by the way, each of these, so this is called an expression. So anytime you have something that with it, like a variable with x and a number, and maybe you're adding or subtracting something with it, or even multiplying, that's called an expression because it's not like something known, okay? So that's an expression that represents those angles. Okay. So same idea though, this angle or that expression plus this angle or that expression plus this angle equals 180. So we're going to treat it the same way. 6x minus 16. Actually, you know what I'm going to do? I'm going to put parentheses around it just like in the picture or in delta math. So I'll do that here. So I'm going to add that up plus 6x plus 19 plus the 57 oops, equals 180. All right, so now we solve it the same way. Now, there's nothing in front of those parentheses to multiply, so I don't actually need to do anything with the parentheses. So technically, you didn't really have to write that down, but I just know that's what it's going to look like when you guys do this on Delta Math. So I'm just kind of showing you from the beginning to end, even though most of you guys, you don't need to write those parentheses down. Unless there was like, you know, a number in front of that, then you would have to distribute it and do all that, you know, those extra steps. Okay, so now here we're going to combine like terms. So I got x, 6x, and 6x are like terms, but we also have negative 16, 19, and 57 are like terms. So we're going to add all those together. So first, 6x plus 6x, that's 12x. And then negative 16 plus 19 plus 57. Why not? Okay, so negative 16 plus 19. There's so many different ways you can get a calculator nowadays. You can bring up Desmos, you can use your phone. Literally, maybe some of you guys know this, you can literally type in the bar up here and start actually doing that and start adding, and it'll also give you the answer up here, by the way, if you guys didn't know that. So you can see here, Google automatically recognizes what you're doing up here, and it'll do the same. So the answer is 60, all right? So plus 60, because it's positive. Okay, that equals 180. Okay, we'll do the same thing like we did here. We're gonna get x by itself for isolate x, so minus 60. Oops, I don't need that there. And minus 60 here. And that's gonna equal 120. Divide by 12. X equals 10. Okay, now go back to again, what is the question asking for? It said solve for x. So is that all we got to do? Yes. So we'd be done if that's all the question asked for. And when you guys are doing Delta Math, that's really all it's asking for when you go through this problem. So literally I would just type 10 here for my answer. Now let's say you got a question in the future where it actually asks you, what are the missing angles? Okay, well, to find those missing angles, I would take that value of x and plug it into the expression to find those. All right, so first I would plug it in here to x and multiply 6 and then subtract 16. So that ends up being 60 minus 16, which is 44. So that's one angle. And then the other angle, I do the same thing. Plug in 10, multiply it, 60 plus 19 this time, and then that equals 79. Okay, so that's if it asks you for those. It's like if it's asking you for the missing angles, then that's what you're gonna have to do. But again, in this case, it's just asking for x. Talking about some assignments. Okay, so reflections and rotations. All right. So with reflections and rotations, let's look at some pictures. Talked about this a little bit yesterday. If I move this object like that, okay, I'm rotating it. Now notice what happens to the object, or the cat in this case. It didn't change the size. It just moved. It literally moved. So if anything, you're calling these things movements without changing the size. That's called a rigid rotate or transformation. Rigid just means like something that's like immovable. It doesn't move, right? Like this table. Like I can't like squeeze it down, right, and make it smaller. It's rigid. It's like I can move it around the room, my desk that you guys can't see in right now. I can move it around the room all I want, but no matter where I move it, if I flip it upside down or put it on the roof or put it outside the classroom, it's still the same size. So that's a rigid transformation. So I'm moving it different ways, whether I'm turning it, flipping it upside down, okay, or just literally pushing it to a different place. It's not changing size. Okay, so that's a rigid transformation. Then there's another type, which is the one for tomorrow, or actually it's Friday's assignments, where you have a dilation, where something's getting bigger and shrinking. Okay, so here, sliding or moving to the right, and I'll let you guys kind of do that one because that one's not too bad. Once you do the notes, you'll get that one. I want to focus more on the ones that I think you would have more trouble with. Okay, so let's just take a look at the IXL, kind of introduce it. So here we're starting with this one on the left, and it moves to this. So what just happened? Well, you have reflections, which are, if you think about a reflection, why it's called a reflection, if you look at yourself in the mirror, it's yourself, and actually you guys can see that mirror right there behind me. Okay, put my hand up there. So you can see my hand in the mirror, but it's flipped around, right? The image is flipped in the mirror. So all a reflection is just you're flipping something. You could be flipping it like vertically like this, like, I don't know, here's a remote. If I flip it like that, all I did was flip it vertically. Or what we say is we flip it over, let's say the y-axis is right here. In the middle, I flip it over the y-axis. Actually, that's a bad thing to use because it's not even. Oh yeah, let's do a ruler. Okay, so here in the ruler, if I flip it, let's say that's the axis, I flipped it over the x-axis. Now let's say my arm is the y-axis now, right? If I flip it this way, now I'm flipping it over the y-axis. So there's different kinds of flips. You can flip it vertically over x, you can flip it horizontally over y, or you could flip it diagonally over a line. So let's say you have like a line or something graphed, and your object is like this, and I flip it over that line. Okay, now that's a reflection over some kind of line, all right? Maybe it's not an axis. So those are different reflections. So that's what's going on here. Okay, now this one, if I took my F and I flipped it upside down, would it look like the second image? No. If I translated it, which means all translate means is you moved it. I went from here to there. I went down, I went up, I went left, I went right, or maybe kind of like moved at an angle, like diagonally or something. That's a translation. So it should still be right side up then if it's just a translation. So that means it rotated. So if I'm looking at the F, really what it did is it just kind of like went backwards. It rotated this way, okay? I wish I had an F to actually hold up and you can kind of see that. All right, so actually here, for some of you guys that are very visual and it's hard for you to hear what I'm saying, this might help. There's my F, right? And all I did was rotated it. So that's a rotation, right? If I flipped it, I kind of have to flip it like this. That's what it should look like, but it didn't, right? I rotated that thing. All right, so that's a rotation. Now here you can see that it's still right side up, this G, and it just kind of like moved up a little bit. So that is a translation. All right, so that's what that's all about. Now let's go to the delta map. Okay, so you'll see there's a bunch of different ones here. You're kind of repeating the same one, but you're doing like, one problem at a time. So let's open that up. Let's go to, I think I need to go to sample. That's probably the best way to get there. All right, so here we go. Let's start with the first one. So reflect the figure over a line. Okay, so remember I told you sometimes you reflect over an axis, like the y-axis or the x-axis, or sometimes you're going to just flip over a line. So after you flip over this line, what does it look like? Well, the way to help you see it, a flip, is think about where the points of that picture are going to go. Make sure I'm recording. Okay, so if I'm going to flip, let's say, just focus on one point at a time, right? So this point right here at -6 and 7, if I flipped it over that line, where would it go to? Well, it's 1 unit away from that line. So that means it will be 1 unit away on the other side of the line. Okay. Then I go to the next point and say, okay, if I flip this over the line, where would it go? Well, it's 2 units away. So I'm just going to flip it 2 units away over the line. And then the same thing with this point down here. This is 3 units away. So I'm going to flip it 3 units away over the line. So now there's the new object, and now it's flipped over that line of x equals -5. Okay, so when you do these problems, just think about one point at a time. Where's that point after I flip it or rotate it? Where's it going to go? And then go to the next point. And then you start to kind of put this image together as you go through it. Okay, and it kind of shows you like a little visual of what that looks like, you know, if you were to like take that object and flip it over. Okay. All right, so here, same thing, except now you can see the line is horizontal. You can see it says flip it over the line y equals -2, or horizontal line. So basically I'm going to just flip vertically this time, basically. So start with this point here at 3, -5. I'm going to flip it up 3 units. So up 3 units there. Then this point down here at 4, -9. Well, that's 1, 2, 3, 4, 5, 6, 7. 7 units away from the line. So I'm going to go 7 units above. 1, 2, 3, 4, 5, 6, 7. Okay. And then here, this is 2 units away. So I'll just go 2 units above. And then there's the object. Okay. So now it's kind of flipped over, you know, flipped over the line. All right. And here's what it would look like if I actually did that flip. Boom, there we go. Okay, so we saw one that's flipping over a y axis or a vertical line, and one that flips over a horizontal line. Okay, and the different results from that. Okay, so let's go to the next section. Okay, so now rotate a figure around the origin. Okay, so now we want to do the same thing, 1 point at a time. By the way, don't forget, if you need help with these and you want some instruction, you can click on Show Example, and it'll show you example of what to do. And you can see here, what it's telling you is that the first point, -4, 4, moved to 4, -4. In other words, this point right there to the left, right there, it flipped around 100 and let's see, how far are they going here? 180 degrees all the way to here. Okay. So if you were to make a circle around the origin from there, it would basically rotate straight across 180 degrees. Okay, then this point would do the same thing. It goes kind of straight across 180 degrees. Okay, from there to there. And then this point does the same thing. Goes straight across. If I could draw a line going straight across, actually I can. Let's see if I can do it. There we go. It draws a line straight across from there to there. This point goes straight across from there to there. And then this point, oh, sorry, I drew the wrong line. My bad. I meant to go from here all the way to there. Okay, and then this one goes straight from there to there. Another way you can figure this out is think about where is that point on the origin? Okay, or from how far away is it from the origin? Like think about slope. So like this point, for instance, right here, let me clear that, clear all drawings and close that. Sorry, I'm trying to zoom in. This, since I'm going 180 degrees, that means I'm gonna go from this quadrant up here, quadrant 2, and go straight across to this quadrant, right? So that means I need to go from that origin down to over 3. Okay, so what I'm going to do now to go 180 degrees, I'm going to go down 2, then over 3. So it's almost like slope. Same thing with this one. I go down 4, over 4, down 4, over 4. Okay, and again, I'm looking at how far am I going from that point to the origin, like you would measure slope. So this one up here, I go down 7 over 1, down 7 over 1. Okay, because it's straight across. All right. Now let's look at a different example, because like if it's not that, like this, 270 degrees. Well, where would that go? Well, 90 degrees would mean it would go from, let me get my little drawing thingy. 90 degrees would go from here to there. 180 degrees would go from here to there. Because this is quadrant 1. This is 2. This is 3. And this is 4. Okay. So again, if I go straight from here, from one quadrant to the next one over, that's 90 degrees. Oh, this is terrible. Sorry, my handwriting. Okay, if I go not only to the next one, but the next one over that, that's 180 degrees. Okay, now if I go from here and go 1, 2, 3 quadrants, and rotate 3 quadrants, that's 270 degrees. So that's where I want this image to go, okay? And I want to use the same idea of kind of tracing those points to get to that new one, all right? So can I turn that off and then focus on the points? Okay, so what I'm going to do, let me see if it'll let me click on it. Draw a circle. Draw a circle centered at the roots. Okay. Okay, so what you're going to do is you click on, oops, sorry. You click on it wants you to draw a circle first. So you click on the center and kind of drag out until you get to a point. Okay. Now you're going to click and drag draw a line through the yellow center and the vertex on the circle. Okay, so basically I'm drawing a line from the middle to that point, to one of the points, okay? Now, you can see that line right there. Now draw a line through the yellow center that is perpendicular to the line you drew. So this is kind of guiding you through, by the way. Here, let me get rid of this, the drawing, so it's not in the way. So basically, just follow the directions as it guides you through. So now draw a line that's perpendicular. Well, perpendicular means that, oops, sorry, I meant to turn that off. Okay, so now I'm going to click and make sure my line is perpendicular. In other words, it should be like at 90 degrees, like this. Okay, and that's going to help me figure out where my next point is going to go. So now it says rotate the point 270 degrees. So now what I'm doing is I'm clicking and I'm dragging it 270 degrees. So if I start here, I go to here, that's 90 degrees, 180 degrees, and then 270 degrees. Okay, and then what you can do is you can kind of click the animation, you kind of see it go, just to make sure that you feel like you did it right. And now what you got to do is draw the new points. Okay, so first I started off with 4, 2. And that point right there, as I watch it go around the circle, became 2, -4. So now 2 minus 4. The point that's at 6, 1, right here, that rotated around and now became this point at 1, -6. And I'll do one more example. I'll do another one because I know this is a tough one. Okay, and then the last point is this one at 8, 4. That rotated around all the way to here and became 4, -8. Okay, so try those values. It says you are correct. Now you may press the submit button. So basically it's walking you through every step as you go through this. Okay, let's try one more. Okay, so now again, we're going 180 degrees, which means we're going to, and it says clockwise, which if you guys remember, pay attention to which direction it's telling you to go. So remember, clockwise would mean I'm going from here to there, this direction. Think about it, the way a clock rotates, right? All right, so first it wants me to draw the line or draw a circle from, click on the center and drag it out all the way till I get to a point. You can see it's kind of lined up with a point now. Then I draw a line, I click and I drag from the center to a point. Then this is where you draw the line perpendicular to that line. So now I click and drag until I feel like it's perpendicular to the line. About right there. No, right there. That would be perpendicular. Okay. Oh, no, it didn't like that one. So let's try it again. So the nice thing is it's going to tell you if you're wrong as you go through this, once you get it right. So it looks like it's there. No. Oopsie, sorry. All right, let's see here. There we go. So now I'm lined up, okay? Now what I'm going to do is it wants me to rotate 180 degrees. So I click on the red dot and I drag it 90 degrees. Remember, we got to go clockwise. And then 180 degrees. And now you got to rename all those points. So this first one at -5 and -3, that's this one here on the bottom. That rotates and becomes 5 and 3. Okay, this next one point, look at this one. This is -5 and -6. That rotates and becomes 5, 6. So that's, oops, I put that in the wrong place. This one's 5, 3. And then this one becomes 5, 6. And notice how the points are very similar, right? But the only thing that's really changing is the negatives. Okay, and then the last one would be this one, -2 and -7. That rotates and becomes +2, 7. Okay, says I'm good. I'll press correct, and then it would, do the little animation to show me the rotation, all that good stuff. All right, any questions on that? Okay. All right, and I'm gonna go over just one more since I'm kind of running low on time here. This one here. So determine a series of transformations that would map figure I to figure J. Okay, so we're gonna go from here to there. So here you had to come up with some transformations that you feel like are gonna help you get from that one to that one, okay? Well, it says to go from I to J. So that means I'm gonna go for the one on the bottom up to J. So what could I do to get it from the bottom to the top? Well, I'm looking at it and it looks like if I flip it up, that will kind of get it to look the same, but it won't be in the same spot. Okay, so we'll start with that. So first I'm going to reflect. Now, if I'm going to go up, okay, that means I'm probably going to go over the x-axis because I'm going to be flipping over that line in the middle. Okay, then I think what I'm going to have to do is then shift it over, kind of shift it back or translate it. Okay, and I think if I flip it up, let's say to here, I'm gonna have to shift it over 3 units. So let's see if it works. So it flips it up and it shifts it over. Okay, not quite. Okay, so this is the one you're gonna have to kind of play with it and figure out, okay, should I try a rotation? Maybe a rotation would work. Okay, maybe I should try to rotate it. I don't know, if I go to 1, 2, 3, Okay, well, that would mean I'd have to go 270 degrees, so that might not work. So maybe we can go like 1, 2, and try that. Okay, let's see what happens. So that means it would be up here, and then maybe I can flip it back this way. Okay, so rotate it clockwise. Okay, it's going to go around the origin. And then what we'll do is we'll reflect it over the y-axis. Let's try that. Okay, so that didn't quite make it either. So as you work through these, you're going to want to like keep trying until you land on the one that works. Okay. And I think, honestly, I think for this one, I'm going to change that to just 1. Get one of those right, because that could take a few minutes for you guys to figure out which one to finally get to. So I'm going to change that to 0 out of 1. All right. All right. So this one, you're just identifying what type of transformations these are, going from one figure to the next. So that's kind of the last one here. Okay. All right. I want to stop here.